Okay, in this video, we're going to talk about constant velocity XT graphs, all right? So those are position time graphs for constant velocity. This is the foundation that we build off of, so this is first unit stuff, but a good reminder, because if we can understand these well, then when we add acceleration to it and it changes the shape of it, it makes sense as to why, all right? And so if we take a look at this graph, right, we're doing constant velocity. This is an XT graph. Let's say you had something that looked like this. How do we interpret what is going on? All right. So if let's use red. All right. So this is our origin. All right. That is the 0 point. This is our origin. All right. This is only on XT graphs. Origin is not located on a VT graph or an AT graph. All right. So if you see 0 on those, it means something different. Position time graph, it means 0. So we're going to say if we have this kind of meter stick down here, that this is my origin, my 0 meter mark. All right, so we're going to kind of use these in tandem. Now, time begins, and as time is going by, I am moving away from my origin in the positive direction. All right, so I see positive, negative. That means I'm moving that direction. It's a positive direction, is positive motion. It is a straight line, meaning there is constant velocity. And if we found the slope, right? Okay, the slope equals the velocity. All right, remember that. All right, this is going to be a positive velocity. All right, it's going to be constant. We're only working with constant velocity when there's a straight line on an XT graph. All right, so we have the slope of this line equals my velocity is positive because it's going up and to the right, and it's constant because it's a straight line. All right, so I'm moving away from the origin in the positive direction. So it would be as if I started here, I'm moving this direction all the way until the 5 meter mark. That's where I stop. Then for a second, all right, this is 2 seconds, 3 seconds, it's flat. All right, so if it's flat, what does that mean? It means that as that second went by, I stayed at the exact same position, meaning I didn't move. So this right here means I'm not moving. All right, so I've essentially stayed right here as time went by. Flat line on an XT graph, horizontal line, the slope of that is 0 because there's 0 velocity. It's not moving. All right, then now I'm going back this way. So I look at this, the same things apply. The slope equals the velocity. Okay, but now if I take a look at this and I actually calculated the slope out, which we could with the numbers if we wanted to, we find that this is a negative constant velocity. All right, and for the first 2 seconds, or from 3 to 5 seconds, I'm moving towards the origin, but then I get there and I keep going. So now I'm moving away from it in the negative direction. So it's as if once second 3 begins, I start moving this other way. And I hit here at 5 seconds, but I just keep going past it until I get to negative 5 meters. All right, so this is negative 5 meters. All right, so I went from 5 all the way to negative 5, so I moved 10 meters total, and I went in the negative direction. So I'd have a negative because it's down to the right. Again, if you took the slope of this, you would get a negative value. So this is a negative constant velocity moving towards the origin here, and then after that, I'm moving away. So if I cross this line, all that means is I've crossed my origin, whatever point I decided to be 0, which is arbitrary, and I get to choose it. All right? So up and to the right is positive. Straight line is constant velocity. Horizontal line means I am not moving. Doesn't matter if I'm up here or down here. If it's horizontal, I am not moving. All right, then I'm going down to the right. It's a negative slope, so it's a negative velocity. Straight line tells me it's constant. All right, then I decide to travel past the origin point. And then I'm moving away from it in the negative direction. All right, so it's negative here So this is how it would look on on this guy. Can't remember the name of it all of a sudden. All right, so I went 5 to the right in the positive direction, turned around and went all the way back to -5 down here. All right, so these explain the only shapes you're going to see when there's constant velocity present. Positive velocity, not moving, negative velocity. Hopefully that clarifies a few things.